Hi, welcome back. This is the next section of geometry, 7.5 proportions in triangles. Our objective is to use the side splitter theorem and the triangle-angle-bisector theorem. It's essential that you understand when two or more parallel lines intersect other lines, proportional segments are formed. So you want to now write down this theorem, the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, and it divides those sides proportionally. So in this picture, RS is parallel to XY. That's what those little arrows mean. That means that it splits these sides proportionally. So one way you can remember it is XR over RQ is equal to YS over SQ. You could also write this as QR over XR is equal to SQ over YS. And then you could also write this so that QR over QS is equal to RX over SY. As we've discussed throughout this chapter, it's just important where you put the matching pieces. They have to correspond, the proportional pieces. So what's the value of X in the diagram at the right? So because KL is parallel to PN, then we know it cuts these sides into proportional pieces. So we know that 12 over X plus 1, MK over KP, is equal to 9 over X. You can use your cross product property here to solve for the value of X. So we would find that X is equal to 3. You can then substitute that value in to make sure that you're right. 3 plus 1 is 4. 4 times 9 is 36, and 12 times 3 is 36. So you know that you're correct. Let's try this next one. What's the value of A in the diagram at the right? So you want to set up your proportion the same way we just did in the last one. These are parallel lines, and therefore when they are cut by these transversals, we know a whole bunch of stuff about their angles, but we also know that they cut these proportionally. So take a minute and set up your proportion. Pause the video, see if you're correct. So if you set up your proportion in this way, or in a way that's similar to it, that when you cross multiply, you would say A times 18 to get 18A, and 12 times A plus 4, remembering that you have to distribute to solve. Pause the video, solve for A. There you go. So you should have gotten that A is equal to 8. If you substitute in that value, you should say that 8 over 12 is equal to 12 over 18. When you cross multiply, you are going to get 144 equals 144, so you know you're right. So the corollary, remember corollary is something that you can easily prove. It's an add-on here to the side splitter theorem is this. If 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. This isn't just true of 3 parallel lines, though. This is an infinite amount of parallel lines and an infinite amount of transversals, but the idea here is the same. If you have parallel lines that cut transversals, at least 2, then it cuts these pieces into proportional pieces. So AB over BC is equal to WX over XY. It's also true that either of these pieces over the whole is equal to the piece over the whole. So let's use this corollary. 3 campsites are shown in the diagram. We want to find what is the length of site A along the river. Well, this is site A. Here we have 4 parallel lines cut by 2 transversals. So we want to set up a proportion. Pause the video, set up your proportion, see what you wrote. Compare it to what I have. So you could have written your proportion either one of these ways, or you could write either one of these ways, but the reciprocal. You could flip them. 9 over x equals 7.2 over 8, or 8 over x is equal to 7.2 over 9. Either way, you're going to use the cross product property, and you're going to get that 7.2x is equal to 72. So x is equal to 10. Now, you need to use a unit of measure here, because in this word problem we have units of measure, so it's 10 yards. Would be your final answer. The next theorem we're going to explore is the Triangle-Angle-Bisector theorem. Bisect, remember, means to cut equally into two congruent segments. So the bisector of an angle of a triangle divides the opposite sides into two segments with lengths proportional to the sides of the triangle that form the angle. So in this theorem, this ray AD bisects this angle CAB. It cuts them proportionally so that CD, this side, over DB, this side, is equal to this side over this side. So you could write this proportion this way, or you could actually write it as AC over CD is equal to AB over DB. That would also work, or you could use the reciprocal of either one of these. You could flip over this one or those ones. So let's use it. Using the Triangle-Angle-Bisector theorem, what's the value of x in the diagram? So you could write this proportion as this. I know this is an angle bisector. So I could say 10 over this piece, 18, is equal to the side that corresponds to 10, 12, over the side that corresponds to 18, x. I could do this, or I could say that 10 over 12 is equal to 18 over x. Either way, when you use the cross product property, you're going to say 10 times x and 18 times 12. Take a minute and solve for x. So regardless of the proportion that you used, you are going to get that x is 21.6, because when you cross multiply, 18 times 12 is 216, and 10 times 21.6 is 216. Let's try this one. What's the value of y in the diagram at the right? Pause the video, try and set up your proportion. Unpause the video and see if what you have matches one of the proportions that I write. So I set up this proportion that y over 9.6 over here is equal to 24 over 16. So that's this proportion here. I also have set up this proportion down here, that 9.6 over 16 is equal to y over 24. Either one of these will work, or the reciprocals of them would also work just fine. So I'm going to use the cross product property. 16y is equal to 9.6 times 24, 230.4. If I did this one, I would get the same thing. And when I use the division property, I'm going to get that y is equal to 14.4. So that concludes our notes. We're going to begin reviewing the chapter, and then we'll be having a chapter test on Monday.